The Knots Company welcomes you back to Focus on Automation, where we explore and celebrate advances that empower manufacturing. Welcome back to Focus on Automation. I'm your host, Todd Youngblood, and today we're going to take a deep dive into a technology that not only has an amazing growth rate, it's one with an accelerating growth rate, autonomous mobile robots. And to help us understand the reality of all this stuff, I'm joined by Mr. Josh Cloer. He's Sales Director at Mobile Industrial Robots, aka MiR. Josh, thanks for joining us this morning.
Absolutely, Todd. Thanks for having me.
Oh, my pleasure, my pleasure. Hey, just to get us started, tell us a little bit about yourself and your background and a little bit about MiR.
Again, my name is Josh Cloer. I'm with Mobile Industrial Robots, really primarily responsible for the eastern half of the United States. My background is mechanical engineering. I went to Georgia Institute of Technology down in Atlanta, Georgia, and out of college worked for an automation distributor, really primarily focusing on machine vision and 3D vision, and also robotics, so industrial 6-axis and SCARA arms. And then the wave of collaborative robots came along and worked a lot with collaborative robots and now into more mobile robots. Right. I've been in the automation industry here for about 5 years.
Talk a bit about MiR. What's MiR all about?
Sure, absolutely. So Mobile Industrial Robots, MiR, is originally a Danish company in the robotics cluster over in Odense, Denmark. There's a lot of new robotics companies coming out of there and a lot of robotics history out of that small area in Denmark as well. We started there back really in 2013, but brought our first product to market in 2015. So we were founded by a Danish robotics professor, Niels Jules Jacobsen, and also he brought along with him a Danish robotics executive, actually, Thomas Visti. He entered our company in 2014 as the CEO, and really when we commercialized in 2015, we started with the MiR 100 and have launched a new product really every year since and spread out more and more until here recently we were privately owned, but in April of 2018 we were purchased by a Boston group, Teradyne, who is primarily a semiconductor test equipment group and brings on robotics companies, acquires robotics companies as more of an investment into the future. And we're happy to be part of the Teradyne family.
Exciting stuff. Before we get into the detail, I want to make sure that well, for myself primarily, we've got some new terminology here. There's AMRs, AGVs have been around forever, forklifts, conveyors. It just position us a little bit, compare and contrast what all those different things are, how they work together, and how they're different.
Absolutely. I think the easiest thing for us to relate to is the AGV because it is automated and it's a vehicle, but we are a little bit different there. But really what AMR is versus AGV, the difference is autonomous versus guided. So being AMR is fully autonomous and kind of self-contained and not reliant on external infrastructure. So AGV, it's that G, the guided, that really is the difference. They're following a set path. It's looking at QR codes on the ground, your typical goods-to-person system or your automotive AGVs that are following a magnetic tape. Those are not fully autonomous because there is, two parts to the system. What's the external infrastructure that may be on the ground or on the walls, and the system that's actually driving. Whereas an AMR is fully self-contained and using sensory data to perceive the room around it and able to localize in that area, know where it is in space with only sensors on board.
I got it. And is it, in your opinion, or in reality, you probably have data for it, I read about the growth rates in this industry that are in the mid to high teens compounded, which is, it's an astonishing growth rate of any technology. What's driving that? What's underneath it all?
Well, I think there's a huge growth rate in general for automation as it relates to material handling. The forklift market is already very, very large, but it requires some person typically to be on the forklift, and that has a smaller growth rate. But the AGV market has a massive growth rate in general. Something like 15 to 16% annual growth rate. But we are just a small subset of that AGV market because AMR is really less than a decade old, really only been commercialized since the early 2010s. So I think the AMR growth rate generally is much bigger, but the market share is much smaller at this time. So we expect to take over more and more of that along the way.
Let's talk about applications a little bit, and maybe you can share a couple of examples. And particularly, I'd be interested in one where an AMR has decided advantages over an AGV.
Yeah, absolutely. So a guided vehicle, again, is following a path. There's specific infrastructure that it needs. You typically have to kind of pre-lay that out physically, whereas an AMR is fully infrastructuralist and uses software to understand its environment along with sensory data on board the robot. So it has advantages in many areas, but the main advantage is that it can not just follow one specific path, but it can create multiple paths and have kind of dynamic navigation. So instead of going around in a circular path around a line, you can kind of choose different paths with that AMR. So a good application is not necessarily, it can be similar looking to an AGV, but the main idea is that the navigation is much more flexible. So it's not having to necessarily do the same path over and over again. It can use different paths and create its own path in real time.
Josh, can you get a little more specific on an application? I mean, in general, I get it. I can move around an obstacle. I can go around it to the left or around it to the right. Maybe you can talk through a specific application to give us a better feel for exactly how that flexibility is valuable.
One of the specific applications that our larger robots focus on is moving pallet loads. Everything starts and ends on a pallet inside of most facilities, and moving your pallets is something that requires typically human labor and also equipment with a forklift. But that's something that you can now automate and also be collaborative in a space. So safe in a space around your operators with mobile industrial robots. So our MiR 500 and our MiR 1000, you have the opportunity to get a pallet lifter along with those robots, and you can move a pallet autonomously and collaboratively in your environment with a MiR 500 or a MiR 1000.
And what about the value of that in terms of dollars?
Yeah, so the value is both equipment, equipment replacement. Our mobile industrial robots, the MiR 500 and the MiR 1000, are generally less expensive and less maintenance than a forklift. But also there's a human there's headcount reduction there, and maybe It's not reduction but redeployment. And so in terms of ROI, you are replacing equipment with more inexpensive equipment and also redeploying your operators to do something more significant. And that's just the demonstrable return. There's also the return of being collaborative and safe in your environment with those payloads, whereas in the past you may have had some sort of liability alongside that forklift operator.
Josh, I'm trying to get my head around all of not only the AMR technology, but how it fits into everything else. Can you talk us through a specific example of what a specific company has done to deploy this technology?
Sure, Todd. I think one of the best examples we have is from Honeywell over in the United Kingdom. They've used our robots for some time now. Back in 2016, actually, they had 4 of our robots with just simple top modules, just a rack where they put a tote onto the top module and used, iPads as their user interface, where they just had the operators press a button to tell it where to go. So they would put a tote on top, press the button, and then it would navigate to the drop-off point where an operator would be waiting to pick up that tote and press the tablet again to allow it to continue.
Really simple then, right?
Exactly.
Yeah.
So no really external systems behind the Wi-Fi except for the Wi-Fi network, and just simple touch interfaces that ultimately are just connected to the user interface of the MiR robot interface. So no real custom integration, all things you can get off the shelf. Very, very simple way to start.
And still valuable.
Yes, and still valuable, and something that can give you a return in less than 2 years.
Wow. And where did Honeywell go from there in this example?
Yeah, good question. So from there, they decided to go more automated. So they actually added a conveyor system to the top of the robot and replaced that rack, and also added some IoT devices, so an RFID sensor that is connected to their Wi-Fi network as well, so that it can communicate with their business level systems. But ultimately, they're using that sensor and the MiR to transport totes autonomously and kind of dynamically. So they'll receive a tote from a static conveyor, and the RFID sensor will read what is inside of that tote. And then in real time, as it comes onto the conveyor and the sensor reads it, determine where to go. Where does that tote need to go from there, and go to that
So
location
I'm
to
sorry to
drop it
interrupt.
off.
So they've integrated it with their production schedule, it sounds.
Absolutely, absolutely. So as a tote is ready to receive, the robot is called. It receives that tote. The RFID sensors determines what's inside of that tote and sends the robot to its next static conveyor location to drop it off.
How long did it take them to get all that designed and implemented?
Yeah, so they started back in 2016 with the manual process, really. Well, I guess semi-manual. The robots are automated and doing the transport automated, but
Got it.
the
Yep.
manual process of on and off loading. But really, they've only done this, I think, dating back to the end of 2017. So it's been kind of a slow process because they've decided to crawl before they walk, before they run.
Sounds like a
Uh,
good idea.
yeah, exactly. We definitely promote, starting with something simple and returnable, and growing to something more automated that will ultimately give you a bigger return down the road. So they've taken it piece by piece, and maybe it's taken a long time, but that's because there hasn't been necessarily a 2-month project sprint. This has been something they've been thinking about since the beginning.
And it's interesting. I guess it depends on your perspective. On the one hand, 3 years sounds like a long time. On the other hand, to have an autonomous mobile robot integrated with my production scheduling system, moving materials around a plant in only 3 years, I'm impressed.
Yeah, it's very impressive.
Josh, I'm sure we could probably spend the rest of the day talking through different examples of that. But just in the interest of time, is there some information available folks can get a hold of examples of different applications in different environments?
Absolutely. So on our website, mobile-industrial-robots.com, we have about 15 different case studies that we've done with partner companies where we actually have a production crew come on site and film the robots in action and have their engineers and executives talk about why they chose to buy our robots and what they've done with the technology.
Sounds like a great resource. When you talk about redeploying folks into different kinds of work that are safer, more interesting, more challenging, more rewarding for the people, it makes me wonder about the skills required. Certainly, there's some programming for the AMR that's required up front, and I would guess there's some integration with other. You mentioned collaborative robots, so integration with other robots and other pieces along an assembly line or in a warehouse. Talk about the skills required to get one of these systems implemented.
Yeah, absolutely. As with anything, there's a simple way to start, and then you can kind of grow to a more advanced capability. But ultimately, to get started with our technology, it's very intuitive. We've built a user interface that's easy to use. It's a web application, so you can connect to our robots, pull out something like an iPad and create a map there in our interface, tell it where you want it to go. It's very simple, and we've designed it such that a kid with a tablet could begin to deploy mobile robots. Now, along the way, you'll be adding these robots to your Wi-Fi network, and you'll communicate with external systems, and there's some general complexity to that that's kind of inherent, but we simplify that as much as we can and also build our system in a way that is very open. And in that way, you can connect it to not only your industrial devices that are on the line, but also your business systems, your WMS system, your ERP system. So ultimately, along the project, you can grow the complexity and the capability of your robot system.
Now, are these skills that you're talking about, none of them sound particularly overwhelming. Is it something that typically the client would develop those skills internally, or are there external consultants typically involved, or maybe mere partners involved in getting these systems designed and implemented?
Yeah, so our system specifically, one of our unique propositions is that you can do it yourself. It is simple enough that you can do it yourself. You typically have, in the manufacturing space at least, the resources to do that with controls engineers or even just operators. So there is some capability that can be handled on your own. But we also have partners that will help you along the way in training you, and also partners that will build turnkey systems for you. If you want something much more complex, then they can kind of handle it for you.
From the manager's standpoint, if I'm looking to acquire one of these systems and implement it, let's talk through the process. What do I need to do? Let's say I'm the manager of a distribution center, for example. What kind of things should I look for where I can apply this technology and get the value out of it that we've been talking about?
Yeah, so the first thing you need to do is look at how you move your materials today. So if you're using a lot of manual labor to move your materials, there's very likely a fit for the MiR 100 or 200 to move your materials around with kind of a manual offload onload with a rack, or even with a cart system that can be more automatic. We encourage our customers to start simple and grow to more automated systems. So if you just put a simple rack on top of the robot, you can actually get some return on that investment. And a great way to start is to contact your local distributor. We partner with distributors across the globe. Really, in the U.S. here, we have around 30 distributors across the U.S. So there's someone that's probably in your backyard that knows all about MiR and can consult on where you should start and how you should do it.
What kind of facilities would get the most value out of it? I mean, to me, it seems like a distribution center is so obvious. That's all about moving material in and out efficiently and effectively. What other environments is this technology particularly suited for?
Yeah, I think a distribution center is a great environment for our technology. Also, your manufacturing facilities, so moving materials to and from the assembly line, from the warehouse to the production side, in between machines. So yeah, there's a lot of different facilities that are using our technology, and ultimately, we're in every major sector in manufacturing. Automotive primarily has been our largest early market adopter, and where we're getting more and more into the warehouse space, I would say, especially with the creation of the MiR 500 and the MiR 1000 that moves larger payloads, moves pallets. That's something that's been really eye-opening for 3PLs and warehouse managers.
When you say larger payloads, how large are you talking about, Josh?
Yeah, so our latest product, the MiR 1000, can move up to 1,000 kilograms, so 2,200
wow.
pounds.
Okay. That's a ton, right?
Literally.
Yes. Talk a little bit about differentiation. Any kind of market that's got, as you're saying, a 15, 16% growth rate is going to attract a lot of attention. What makes MiR different?
The main difference that we offer is kind of threefold. We have a very simple to use user interface, so you can get started very, very quickly and recoup the investment very, very quickly. So we have a short return because you can deploy these robots in a short amount of time. Also, the openness of our architecture, so being able to communicate with other systems and build things on top of our product, we make that very, very easy.
Systems integration has been a challenge for as long as I can remember, and certainly before that. So that open interface is a big deal.
Correct, and we also have standard solutions on top of that. So we have MiR Go. If you go to our website, and there's a MiR Go section, which is a marketplace for standardized top modules for our products. So third-party companies that have built products, what we call top modules that go on top of the mobile platform, and that makes it it lowers the entry point for integration and allows customers to buy a MiR product and a third-party product that's been hardened and used before and put them together and create a solution.
Interesting. I'm going to ask a question now that's maybe a little bit unfair, but you probably think about it a lot, and that's what's coming down the pike at us. As you look out 3 to 5 years, where's this technology headed? What else is going to get added to it? What do you see coming at us?
Yeah, absolutely. So I think the biggest thing in the next 3 to 5 years is going to be different form factors for this type of technology. So being able to manage different payloads, we can move pallets. We have conveyors for the tops of our robots. We can move carts around. But as people get more creative and have different problems to solve, this technology really lends itself to being flexible in that way, with the open architecture and the autonomous navigation. So you'll see that you can now automate different types of material transport that maybe you couldn't automate in the past just through different form factors. I think that's the big thing for the next 3 to 5 years. Looking beyond that, I think that there will be kind of a lean into artificial intelligence with this technology, along with the adoption of cloud computing and 5G technology. You're going to have a lot of computing power on these types of devices, and as you add more sensory data, between laser scanners and 3D cameras, you'll be able to use those perception softwares in AI to understand the environment a lot better and really connect every sensor on the plant floor or in a warehouse to the robotic system so that it can understand what the environment around the robot looks like a lot better, which will mean, faster robots, better obstacle avoidance, things like that, which will ultimately lead to efficiency gains in your production or in your warehouse.
Boy, it's interesting. I want to hear your reaction to this. As you were just talking about those, future applications, particularly when I think about hooking up every sensor in sight into an artificial intelligence engine, it strikes me that if I'm running a warehouse or a factory, I really need to get into this technology now, because 3-5 years from now, I might be hopelessly too far behind. Does that make sense? I mean, that's just where my brain went as you were talking about where this thing's headed.
Yeah, well, absolutely. As we all know about globalization and the amount of global competition that has come out, especially recently, but also for a long time, and that's leading towards automation in general. And there are those that haven't automated their material transport in any way, and I think that's something that you should absolutely look at here in 2019, 2020. Getting an older technology and bringing that in-house to automate, something like a conveyor and AGV is one thing, but why not start with something that's leading edge? And that's really what an AMR is kind of the leading edge of material transport automation. And if you start with something old today, then it's going to be really old in the next 5-10 years. So start with the best viable material transport solution that will lead you into the future for automation.
Josh, we talked a little bit about getting started in all this, and I want to make sure before I let you go that folks know how to get a hold of you or know how to get a hold of one of the many partners that you've mentioned here to get started in figuring out what application and how to start bolting one of these things together and get it deployed. How do we get a hold of you?
Yeah, I think the easiest way to get a hold of us is go to our website, mobile-industrial-robots.com, and on there you can find your local distributor contact information. You can find our locations information, so MiR East and MiR West. We have an office both in New York and San Diego. So on our website you can find all of those emails and phone numbers to where you can get in contact with us or your local partner.
The web address is?
mobile-industrial-robots.com.
Perfect. Josh Cloer, Sales Director at Mobile Industrial Robots. Thanks for taking the time to share your insights, Josh. We appreciate it.
Thanks, Todd.
That wraps today's episode. On behalf of my guest, Josh Cloer, and our sponsor, the Knott's Company, I'm Todd Youngblood. Talk to you again soon.